Okay, we have learned how to do the basics of stoichiometry in trimester 1. And now we are going to start with a review of that and putting together the whole map. So what I've noticed is some people are using those coefficients from the balanced equation in places they shouldn't. So let's do a review of, first of all, what this first map is for. This first mole island map is for conversions between one substance only. So you're going from grams of oxygen to moles of oxygen or moles of oxygen back to grams. And when we do conversions with one substance only, so we're not going to a different substance, notice our conversions all contain 1 mole. So there are 22.4 liters of gas at standard temperature and pressure in 1 mole. 1 mole contains 22.4 liters. It doesn't contain 22.4 liters in 2 moles. Don't write that, okay? This is your conversion. It can flip, but it can't change. Grams to moles or moles to grams, we use our molar mass, and that molar mass is from our periodic table. Here's your little hint. And for instance, carbon is 12.01 grams for every 1 mole. So 1 mole goes with this conversion, our one substance conversion between units. So let's put that on our full stoichiometry map so you can see what I'm talking about. Here's our full stoichiometry map, which is basically going from moles to moles, okay? And this is between two substances, between substance A in a reaction and substance B in a reaction. And to go from moles to moles, we would use the coefficient from the balanced equation. Now, if we're on this side of the map here, that is for one substance conversions only, and we would use those conversions that are for 1 mole. So let me overlay that map so you can see how that works. So if I put this map right here, you can now see we still go from mole to mole using our coefficients from our balanced equation. But if we're on this side here, which is conversions between just substance A, and by the way, it would be repeated over here, all our conversions contain 1 mole, and we're not using the coefficients from the balanced equation because we're not converting between two different substances. We're just converting grams of substance A to moles of substance A. So make sure that you understand that part. Okay, so just to review, we're using our full map. So we're going to go from grams to moles, that's 1 step. Moles to moles, that's 2 step. And moles to grams, that's 3 steps. So these problems are going to be 3 steps. They might start at liters, gas volume, so it could be liters to moles 1 step, moles to moles 2 step, moles to liters 3 step, and it can go anywhere on these conversions. And there are 6 steps. You got to write a balanced equation. You got to ID your given and unknown. You got to write your path. You got to change the given to moles. Okay, and then we're going from moles to moles. That's our mole ratio. And then we are going to convert the moles of our wanted to the unit they requested. So the first thing I've done is I've split this chart for our first problem already into ammonia side and nitrogen side. So it's helpful for some people to understand what's going on. So we should circle our given. So I have these circles here for you, and our given is 32 grams of ammonia. And that's where we're going to be starting. We always start at our given. And what do we want to find? I'm going to underline grams of nitrogen, okay? So when I go to my path, you can see we're starting with 32 grams of ammonia right over here. So 32 grams. Yeah, it's fun to work with this pen. 32 grams. I'm on my ammonia side. And where am I going to? I want to find how many grams of nitrogen. So I'm on my nitrogen side. So my path is going to go from grams of ammonia to moles of ammonia. And you need to figure out your molar mass per 1 mole for that. Then we're going to go from moles of ammonia to moles of nitrogen using those coefficients from the balanced equation. And then we're going to go from moles of nitrogen to grams of nitrogen, and those are simple mole conversions. So the first thing we need to do is balance this equation, and you're going to find out that you probably need a 3 there, and you probably need a 2 there. Okay, so that's balanced. Our second step is to ID underneath what we need here. So where is my question mark? We're looking for ammonia, and we're looking for it in grams, and this can change. So we need to always make sure that we put what we're looking for, question mark, grams, right under our nitrogen, because we're looking for how many grams of nitrogen gas. And we're given 32 grams of ammonia gas, so I have ID'd it right underneath. If you're doing this on paper, you have to do all these steps, okay? Our next step is to do our path. So we're going from grams of ammonia, I already have that in here, to moles of ammonia, and then I have to go from moles of ammonia to moles of nitrogen, and then I have to go from moles of nitrogen to grams of nitrogen. And again, here is our path on our map, okay? So I always start with my given, and I don't have the highlights here, so if you just click on that box, you should be able to start typing. Okay, I'm going to start with 32 grams of peanuts? No, grams of ammonia. Okay, so now I'm right here on Graham Island. I don't want to be on grams of ammonia island. To get off of that island, I put my units on the bottom. This is grams of NH3 on the bottom. My first step is to go to moles of ammonia, and I have that right here. So my path, whatever's there, should go on top per 1 mole of NH3. Now, where did I get that 1 mole from? That is from your grams to moles conversion, and that's the molar mass per 1 mole. Now I have the molar mass worked out over here for you. Remember, we add up everything, and that's 17.04 grams per 1 mole, but that is flipped. So 17.04 grams of nitrogen per 1 mole of nitrogen. Now, here I am. I'm to moles of ammonia. Do I want moles of ammonia? No, but I can only do one conversion at a time. So now I'm going to go to moles of NH3, or to moles of nitrogen gas. So how do I get rid of moles of ammonia? I put it on the bottom. So we are going to moles of NH3, and notice that cancels that out. And on top here, I'm going to moles of nitrogen gas. And where do I get this conversion factor? Well, this comes from my coefficients from my balanced equation. So for nitrogen, I have 1, and that comes from right here. If there's nothing there, remember that's a 1. And then my moles of NH3, what are my moles of NH3? I have 2 moles of NH3. And that comes from right there, this coefficient. Okay, so now I've gone from grams of ammonia to moles of ammonia. Now I'm going from moles of ammonia to moles of N2, which I just did, and now I need to convert those moles of nitrogen gas to grams of nitrogen gas. So I need to get rid of moles of nitrogen gas, and I need to go to grams of nitrogen gas. Likes doing that. And where do I get this number from? Well, this is my conversion for 1 mole. So for every 1 mole of nitrogen gas, and I have it done right here, there's 2 nitrogen gas atoms, I have 28.00 grams. Let's get rid of that. Okay, now when I put this all in my calculator, I'm going to do 32. We don't have to multiply by the 1. It won't change anything. Divided by 17.04 equals times 1 equals divided by 2 equals times 28.00 equals divided by 1. And you're going to get 26.29. But I only need two significant figures. How do I know that? My given has two significant figures, so my answer has two significant figures. And so that would be 26 grams of nitrogen gas. Now, how do I know that I set that up right and that it's grams of nitrogen gas? Well, my grams of ammonia cancel out, grams of ammonia cancel out. Moles of, or moles of ammonia cancel out, moles of ammonia cancel out. Moles of nitrogen gas cancel out, moles of nitrogen gas cancel out, and I'm left with grams of nitrogen gas. So that's how you do that one. And now we'll do the next one together. So this is my balanced equation from above. And where did I get these numbers from? Well, here is my given. My given is 5.2 liters of hydrogen gas. And how many grams of ammonia? So grams of ammonia is what I am looking for, so I will underline that guy. So I've remade this map, and we are given hydrogen gas, and we want to find ammonia gas, but we're starting on a new island. We are starting at gas volume at standard temperature and pressure. So we were given 5.2 liters of hydrogen gas, and we need to find grams of ammonia gas. So let's find our path. And we are going to start at liters of hydrogen gas, and we're going to go to moles of hydrogen gas. And that would be a conversion factor of 22.4 liters for every 1 mole. And then we're going from hydrogen to ammonia, moles to moles. That's our conversion using our coefficients from our balanced equation. And lastly, we are going to go from moles of ammonia gas to grams of ammonia gas. So a slightly different path here. And I've put the path already in here. You have to have that if you're doing it on paper. Again, liters of hydrogen gas to moles of hydrogen gas to moles of ammonia gas to grams of ammonia. Let's fix that. There we go. So remember, this is a 3-step conversion. 1, 2, 3-step conversion. And we always start with our given. And our given is 5.2 liters of hydrogen gas. Okay? Now, I don't want liters of hydrogen gas, so I'm going to put it on the bottom, and I am going to go to moles of hydrogen gas, okay? So what do I put in here? Well, for every 1 mole of hydrogen gas, there are 22.4 liters, and you get that right off of your 1 substance mole conversion chart, okay? So now I am on moles of hydrogen island. That's what I just converted it to, but I don't want to stay on that island. How do I get off that island? Well, I put it on the bottom right here, which is moles of H2. And what I want to go to is moles of ammonia. Okay, and where do I get the conversion factors that go in here? Well, when I'm going from moles to moles, this is the only time we use the coefficients from the balanced equation. And moles of ammonia from my balanced equation is 2, and my moles of hydrogen gas from my balanced equation is 3. So 2 for my ammonia, 3 for my hydrogen. So now I've converted to my moles of ammonia. And now I just want to take those moles of ammonia and convert them to grams. So I don't want to be on moles of ammonia island. How do I get rid of it? I put it on the bottom, moles of NH3, and I'm going to grams of NH3. And where do I get that? Well, for every 1 mole of ammonia, it is true that I have 17.04 grams from my periodic table when I add all that up. And that is right here for you to review. And when you put that all in your calculator, you will get 5.2 divided by 22.4 times 2 equals divided by 3 equals times 17.04 equals. So you get 2.637. I only need 2 significant figures because of that 5.2, so that ends up being 2.6 grams. Grams of peanuts? No, grams of ammonia gas. So let's just double check we did that right. My liters of hydrogen gas got canceled. That's good. My moles of hydrogen gas got canceled. That's good. My moles of ammonia gas got canceled. That's good. And I'm left with grams of ammonia gas, and that is calculated by multiplying by the top, dividing by the bottom. You should hit equals between every single step. That will take care of any calculator problems you may have. Okay. Please seek help. Do these problems with me if you need more help. This will be used throughout the rest of this trimester. It's very important that you understand how to do stoichiometry.